Thank you, everyone. This is for RD3. We focus on crowd and attack simulation for risk assessment and threat mitigation. My name is Peter Jin. I'm with my colleagues at Rutgers Civil Engineering. RD4 researchers a scholar has provided a summary of how the limitation of the existing microsimulation. I just want to emphasize a couple additional points in addition to the basic characteristics. They are not designed for emergency crowds, but rather normal crowds need the special characteristics calibration to reflect crowds under emergency. We also identify several other challenges. First off, the existing simulation tools mostly are focused on alternative evaluation instead of really supporting real-time decision support that require higher simulation speed. Second is most existing simulation package only provides potential accuracy, a message to calibrate the accuracy at the aggregated level, mostly speed, flow, density, Q-length. But what we are trying to accomplish here together with the digital twin in RD2 is to potentially achieve individual pedestrian trajectory level accuracy. And then with the help of RD1, we can potentially make some of the infrastructure element set up to be more flexible and dynamic. And we're also leveraging some of the study related to sensing line of sight simulation to actually simulate the threats coming from, for example, in shooter scenarios, the line of sight and visual coverage area from shooters and potential safety patrol. All right, so this is our research team, mainly on three tracks. Dr. Padia, his team from computer science, his team focused on the large-scale crowd simulation. Dr. Gom providing the digital twin model, mostly on the infrastructure and also potentially for the coverage area of CCTV cameras. And we kind of tie all of them together as a background, creating the data needed to support the simulation and also develop impact assessment methodologies. All right, so this is the kind of I'll show in several quick slides, the pipeline that we propose for different research tracks. This is for the crowd simulation. So it starts from really an intention-aware crowd navigation, the social force model, the calibration, and moving towards importing the digital twin environment into virtual navigation meshes that can move the agent around, and then towards finally using high performance GPU parallel computing to create large-scale simulation and visualization of the facility and the crowd. This is how RD2 has been helping us in RD3 research scope. Both of we did intensive scanning of our Rutgers Stadium using handheld LiDAR and also drones. And the RD2 team created the BIM infrastructure model for us to be used to be loaded into crowd simulation. We are also looking to adding the context to the digital twin by leveraging the Google Earth and other imagery around, and also the drone 3D model. So this is how kind of our more detailed crowd simulation calibration was carried out. This was really collected through a Rutgers Penn State game, and we applied the latest ultralytics Euler 5 and V8 technology to detect human in a crowded space. You can see the most focus is on detecting human heads rather than the whole body due to the occlusion, and the heads provide a lot more consistent detection. And moving forward, we are providing the trajectory inputs and probably exploring some of the trajectory inputs from trajectory data from RD4 to look at how we can help calibrate further the social force model to reflect some of the queuing dynamics in normal and emergency scenarios. This is one of the ongoing latest research started from year 4. We were looking at using studies we conducted for traffic, for surveillance sensing simulation, field of view simulation to simulate what we call line of sight. So basically from a point source, look at the potential coverage in the 3D terrain coming from the RD2 digital twin model, and how that occlusions and the infrastructure conditions creates potential occlusions to the line of sight. And in the sensing environment, this is to identify what is the coverage limitation, where's the blind spots of sensors. However, when we use that to simulate the threats from, for example, gun shooters, either traversing through a stadium or at some sniper positions like in the Trump assassination, this provides us a way to identify potentially threat areas. For example, as the shooter moving towards the stadium, you will see where the areas that can potentially provide some kind of shelter due to the infrastructure elements. And we can also add some of the suggested RD1 infrastructure changes or temporary sheltering to see how that can make an impact of creating safety passes for crowds to evacuate. On the other hand, on the countermeasure side, we can also look at using this type of simulation to potentially assess what are the potential coverage areas of safety patrol, safety sniper positions to help enhance the security and countermeasure effectiveness. Coming a long way from the initial 5,000 agent simulation, which you can see a little bit scattered around, to right now we can simulate 10,000, and this is really a fully packed full Rutgers Stadium scenario with 52,454 agents. These are all running very smoothly in terms of the evacuation. We were able to load the initial RD2 beam model through FBX and OBJ file to simulate the evacuation. The last one is related to the integration with others I have been described, but one thing I want to point out is the RD3 crowd simulation is really the mashing at the background. So we have the detailed infrastructure model, digital twin model from RD1 and RD2, and RD2 have even one step further to be able to create digital twin on any video coverage areas. And so those trajectories in the ultimate crowd simulation model we want to build will be mimicking the real world trajectories. And the crowd simulation that we're building here will try to mash everything in between. So make sure the in between camera coverage, uncovered area, the trajectory still makes sense and still can be connected. That's the ultimate goal.